So we've been working in section 5.1, taking a look at complex numbers. Just a real quick couple of reminders of where we were. We had taken a look at the definition. I is defined as the square root of -1, or we can say that I squared is equal to -1. And complex numbers have the form a plus bi in standard form. We took a look at the idea that adding means combining like terms, same subtracting. And then when we multiply, we have this extra caveat on top of what normally things have looked like before with polynomials, where if we have powers of I, we're able to reduce them because we know that I squared is equal to -1. And we had done some arithmetic pieces with conjugates for division and had left off right here with the idea of finding the complex components when we have square roots of negative numbers. So sometimes we're able to simplify completely with no radicals, right? When 64 is a perfect square. If it's not a perfect square, we break it down as we have before, and the negative becomes the negative square root, or square root of -1 becomes an I. And then if there's addition or subtraction, we need to make sure that we're careful to do all of what's underneath the radical first before we attempt to bring anything out. Okay, that was a real quick run through. I'm not sure, maybe like 2 minutes. How are we feeling? Does that sound familiar? I hope so, because you probably haven't touched it for 2 days. True? Okay, it's all right. Okay, so we're going to take a look at what happens then when we have additional kinds of operations involved. In particular, we're taking multiplication, but not multiplication of numbers in that a plus bi form, but in that square root of negative value form. Okay, so when we're taking a look at something like this, we've got the square root of negative numbers. These are subtracted. The next one we do, I think, is multiplied. We need to make sure we simplify each of the radical pieces before we do anything else, okay? So that's the operation we're going to deal with first. So we already saw the square root of -81. Yes,
sir? So
sir?
would that be I squared root of 9 minus I squared root of 12?
Close. So not square root of 9, but just 9, right? The square root of 81 would be 9. Whoops. And then the fact that there's an I makes this 9i. And then minus 12i, you got it. Okay, does that make sense? Yes. Because of the negative. The negative underneath the radical automatically means we're going to get an I. Yes. Okay, is everybody at this point cool with that? Makes sense, okay? Excellent. And then if they're like terms, which these are, we would combine them. So 9i minus 12i would be -3i. You got it. Now here's the deal. There's nothing on your calculator that allows you to sort of like cheat the system here. You don't have any tools inside of your calculator that work with imaginary numbers this way. So this really does push back into there's not a real good check. Okay, you can't check your work in this situation very well. Okay, like I know you have AI tools and things like that you can check with as you're doing your homework, and that's fine, you can do that. But there's not a way to check with resources that are at your disposal in more of a confined environment. So we need to make sure that we understand how to simplify these radicals independently of that. It's real tempting when you have something like this to work with this kind of like we would have worked with others before. We still need to be careful that we're dealing with the square root of negative radical part, that radical part first. So I'm going to deal with that before I even deal with the square on the outside. When I have the square root of -11, what do? There's not a lot I can do, but what can I do? You can pull out an I. Okay, the negative underneath the radical means there's an I on the outside of the radical. That's the alternative form. So the first thing I'm going to do is to rewrite this like this. And while we mentioned it last time, I'll mention it again. We really do want that I written in front, even though the form is not standard form, because we don't want it to ever look like that I is underneath that radical, okay? I's do not go under radicals. That is not a thing.
So in my MATLAB, is it going to look like that?
I don't know. If it doesn't, just be super extra careful as you're doing your input that it's not underneath there. I don't think it has a problem with the I in front, though, if I'm remembering right, but I could be wrong. Yeah. It doesn't have a problem with it. Fantastic. Let's put the I in front every time then. Thank you so much for somebody checking. All right, what does it mean when we square something? Like this says there's something being squared. What does that mean? It means what? It's going to partially get rid of the radical, but I mean something before that. Before we actually look at the logistics of what it does, super details. It means you're going to have to say it louder, Deacon. It means you're going to have to FOIL. Right, when we have something squared, what it really means is that we have it multiplied by itself. And what that boils down to is the fact that we need to make sure that we FOIL. Okay, it is tempting to think that we can just square each of the components inside, and we absolutely cannot. And I'm going to remind you why, because we've seen it before, but we're going to see it again. If we had, let's do 3 squared plus 4 squared, and we also had 3 plus 4 squared. Let's say we have this, okay? The temptation is to think that somehow these are the same expression. And that's what it would be if we just distributed a square over these pieces that we have. But 3 squared is 9, and 4 squared is 16, and this total is 25. But if I add 3 and 4 together first, and then square it, I get 49. There is no distributing squares. You cannot do that. It will not result in the right value, okay? So we do have to do what Deacon mentioned. After we get this written out, we're going to FOIL. So when we multiply our first terms together, -2 times -2 is 4, right? My outer terms actually will end up meaning there's going to be a radical still here, right, Keith? Yeah. So I'm going to get a -2i squared 11 when I multiply the -2 times the I squared 11. My inside terms are going to give me that same value, -2i squared of 11. But then on the last terms, we are going to get some simplifying of some radicals. We've got I times I, that's I squared. Whoops. And then we've got the square root of 11 times the square root of 11, which is 11. Okay? Some of these can be simplified, some of them can be combined. I've got a 4 at the beginning. These two add together because they are alike, so there's -4i squared 11. And then the one at the end, remember I squared is equal to what? -1. So this at the end is actually -11, right? And that -11 will then combine with my 4, -7 minus 4i squared 11. Now, do you have to show every single step? Well, some of you don't. Some of you can definitely skip some of these pieces. Just be careful to make sure that you're not skipping important pieces that lead you down the wrong track. We don't want that to happen, of course. But if you can compact a few of these steps into a single step or whatever, then that's fine. Either way, if you do that or if you do this all written out, you should be still getting this answer. All right, any questions on that? Okay, we've got a couple more, the same kind of variety where we're simplifying numbers, right? So on this one, we have division, but the division's not ugly like last time. There's just a single thing down there, right? And it doesn't have an I in it. So this is not ugly division or conjugate division like we did last time. It's not. And we do have the ability, still looking at this, to see that I've got a negative underneath a radical. So that negative underneath the radical is still the first place I'm going to start. So we understand that the negative underneath the radical means what? It means I on the outside. So the very first thing you're going to do, and you can combine this again with another step if you wish, but I'm just going to write it separately, is that we're going to write this like this. Everybody good with that? Okay. Now 18 is not a perfect square, right? It's not, but it does break down. How will 18 break down?
3 squared.
All right, so there's a 3 squared and there's a 2. Or if you don't think of it as 3 squared, you think of it as 9, that's fine as well. So this is the number 9, yeah? So the 3 squared, or the 9, is a perfect square, which means the 3 will come out. The 2 is not, so the 2 will stay under. So the -15 doesn't change at the beginning. 3 comes out joining my I, and 2 stays under. Okay, are we all right? Everybody good? That's algebra simplification, but it might have been a minute. Okay? Now we're going to break them apart so that each of the fractions is written over the 33. Okay, on this one, it won't change a whole lot if we compacted it and did it all at once, but on others of them, they might. So I want to see them written that way on this one so we can make sure we understand what's happening. I'll write it like that for now. Okay, so 15 and 33 will both divide by 3. So we're going to divide them each by 3. If I divide 15 by 3, what do I get? I get 5, or negative 5, yeah. And 33 divided by 3, 11. So this beginning part right here is negative 5 over 11. Is that okay? All right, the next one's also subtraction. 3 and 33 also simplify, right? They both, again, divide by 3. So that was what I was referencing a moment ago, that we could have divided these by 3 up here. But in general, these would not have both had to divide, and this would still be able to be written this way and simplified. Or they could be simplified and divided by different values, not both by 3s. So these do both divide by 3. So this is a 1 and another 11 on this one. So we end up with I. You can write the 1 in front if you want. Square root 2 over 11. Alternatively, just let me show you, this is perfectly fine. I don't want you to have to change anything, but I just want you to see, alternatively, you could write this like this, where the I is at the back. On this one, I think the I being at the back is a little bit less confusing to be underneath the radical because it's down beside the fraction instead of up in the top with the fraction. So, is that okay? So I don't need you to change it into that, but if you saw it changed into that, I want you to recognize that it is the same thing. All right, I think there's one more, is that right, in this section? All right, let's take a look at it. Okay, so there's a property of real numbers. I'm going to write this to the side. This is not a property we can use right now. This is a property of real numbers. Do you remember what kind of numbers we're working with? Different word. It does start with a C, though. Complex. These are complex numbers. Complex means that they've got negatives and radicals. So let me show you the property of real numbers that's tempting to use because I want to sort of address the elephant in the room in case you're thinking of it so that you don't do it, okay? There's a property of real numbers that says that if I have square roots like this, A and B, I can multiply them together underneath the radical. Okay, that's a property of real numbers. That is not a property for the complex numbers. Let me do the problem correctly, and then I'm going to show you what would have happened if we had incorrectly assumed this. Sound good? Because I don't want you to incorrectly assume it, so I want you to see that it really doesn't work. So if we do the problem correctly, we understand that the negatives underneath the radicals become i's on the outside. Right. So we're going to do that first. I'm going to write a 3. I'm going to write an I, and I'm going to write square root of 7. And I'm going to write 2, and I'm going to write an I, and I'm going to write square root of 8. Okay, pretty good so far. Now, we could combine some pieces and so forth, but I kind of want to simplify the radical a little bit further. 7 doesn't do anything, right? 7's prime, I can't do anything with it, but 8 will simplify. If I take the number 8 and I break it down, what do I get? 4 and 2. Or if you prefer, we could write it as 2, 2, and 2, right? Either of those are possible. If you think of it as the 2, 2, and 2, you've got partners that are 2's. If you think of it as the 4, you recognize the 4 has a perfect square root. So either way, if you think of it as I take the square root of 4 and I get 2, or I'm looking for partners, 2 has a partner, so I get 2, we still get 2. So what that means is that, rewrite the first piece, and this 2, and this I, that there is a 2 that comes out from underneath the radical, and there's a 2 that stays underneath. Now I realize that's really ugly and messy looking. We're going to clean it up here in just a second. But the 2 came out from underneath, and there was a 2 that stayed underneath as well. Right? Because the square root of 4 is 2, or we've got these double 2's, so 1, 2 comes out. Okay, is that okay? So combining the pieces that are there, I can combine all factors that are multiplied outside the radical together. 3 times 2 times 2 is what? Don't overthink this. 12, thank you. Fantastic. Then I can combine the pieces that are i's. I times I would be I squared. And then I do have this property over here on the right that says that the 7 that's underneath the radical and the 2 that's underneath the radical can in fact be multiplied for a 14. Okay? I'm almost finished. Why is this not completely finished at this point? Because it has I squared in it. No powers of I can stay in the problem at the end. They will simplify. Of course, that I squared is equal to what? -1. So I can simplify this to -12 square root 14. Okay, is that all right? Okay, so let me show you what happens if you assume this property on the right-hand side would have worked from the get-go. You ready? If we assume this property works from the get-go, I'm going to be able to multiply the 3 on the outside. Let me write them again over here so you can see it. I'm going to multiply 3 on the outside and the 2 on the outside. That gives me 6. And then I'm going to be able to multiply my -7 and my -8 underneath the radical, if this property were true. What's going to happen when I multiply -7 and -8? It becomes positive, and that is exactly the problem that happens. Because it becomes positive, it becomes a 56. We're not going to have that I squared now on the outside that's then going to become a -1. It's just not going to be there. The breakdown will still be the same. I'll still pull out a, what did I pull out before? A 2. Is that all I had? Yeah, a 2. And then there was a square root 14. So I would still end up with a 12, and I would still end up with a square root 14, but I would not end up with a negative on the outside. And that's wrong. Like it is incorrect. And the reason it's incorrect is because that property is a property of real numbers, not of complex numbers. Okay? So the key here is deal with the square root negative parts before you do anything else. Okay, so this is a big no. This doesn't work. If you wrote it down, make sure you mark it out and tell yourself, no, 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 don't do this. I always hesitate to put something on the board that's wrong because I want to make sure that you mark it out and make sure that you know it's wrong too. Okay, how are we feeling? We're okay? Okay, that's it for section 5.1.